So, what is meant by arrays? Array is a collection of homogeneous data types as well as it follows only contiguous memory allocation. That means elements are stored in sequential order. They cannot be stored. One element can be stored in first location, next element can be stored somewhere else like that. Only they can be stored in adjacent locations. Okay. So, this is opposite to that. So, what is meant by linked list? Linked list is a collection of homogeneous or data types. You can either store homogeneous data types or heterogeneous data types in the linked list. And one more point, this is a collection of non-contiguous memory allocations. So, in the previous array storage, we had got a problem that you cannot store all the elements in random positions. So, what is meant by non-contiguous memory allocation? In the arrays, we have stored all the elements in sequential order. Here, you need not store all the elements in sequential order. You can store them in random memory allocation. The main parts of a linked list are head node, that is head pointer, and nodes. There are two important parts for the linked list. That is, one is head pointer and nodes. Okay. So, what is meant by node? The individual element in a linked list is called as node. In general form, when you try to store a variable, how do you store? Int a equals to 10. So, a is a variable. So, you find some location for a, then store here. Okay. You don't need any other values associated with this variable. It can store only one value and no other value is linked with this, right? But in linked list, you have connection with the other elements also. Because what is meant by linear data structure? You try to connect elements, okay? Each element is connected to the other element in one or some other way, okay? So, this is what is going on here. So, in linked list, we have nodes. A node has two different parts. First part is data part. Next part is next address. It contains the address of the next element. Okay, I will explain you in detail. So, this is my head pointer. Okay, what is meant by pointer? Pointer stores the address of another variable. So, this head only stores the address. It does not store any value like this. Okay, pointer stores only address of another variable. Now, I have considered a node 10 and it is being stored. My RAM has memory space at 100 location and I've stored 10 here. So what is stored over here? Are there any elements after this? No. Since there are no elements, you can write null here. Okay. If there are any other elements, you will write that address over here. Since there are no elements over here, you will write null. So always this head points to my first node. What is my first node over here? 10, right? What is the address of 10? 100. Okay. What is the address of 10? It is 100. My head pointer only stores the addresses, right? I have to store here. In case, if you particularly mention it as head pointer, okay, then it stores addresses. I'm not going to point it like this. Now you can store values. But with my concept, I will store only pointers over here. Okay. Now I try to add an element here. My second element is sum 16. Are there any elements after this? No. So, random location. I had space at 1600 location. So, I have stored 16 over here. So, after 10, are there any elements? Now, I have added element. So, my next element to 10 is 16. So, this is connected to this. This null changes to, and now this is pointing to this one. So, 10's next address is 1600. Okay. So, before previous case, 10 does not has any other elements after 10. Okay. Now, I have an element 16. Location is 1600. Why? What is the reason for taking 16 and 1600 over here without taking the data address? So I am trying to store any pointers here. This is my data part and this is my next address. The element which is next to my node, I will store the address only. I will not store any values in this next part. So this is meant by linked list. Today we are going to learn the topic types of linked list. We have three types of linked list. Those are, one is single linked list, second one is double linked list, and third one is circular linked list. Okay, I will explain you each topic in detail. My first one is single linked list. Single linked list is a linear data structure which follows non-contiguous memory allocation. Okay, single linked list has two important parts. Those are called as, first one is a head pointer and my second one is nodes. Okay, so the main point you have to remember is, for the entire list, there will be only one head pointer. Okay, there can be any number of nodes, n number of nodes, but there can be only one head pointer. So what is this symbol? We have gone through the topic pointers, right? Pointer is a special type of variable that stores the address of another variable. So let me show you how this pointer is being used in a linked list concept. Say for example, so this is my variable int a equals to 10. Okay, so in my memory, there is a variable called a. Okay, say for example, it is stored in the memory location 1000 and my element 10 is stored over there. Okay, after that, I will declare a pointer int star p equals to address of a. This symbol is called as asterisk. In case if you are not able to spell that symbol, you can use it as star p. Or this symbol is called as ampersand. Okay. So this I will be calling it as NA. Okay. So I've stored the address of A in P. What is my address of A? That's 1000 and star P is holding the address of 1000. Right. So in our memory location, any element which is stored in my memory location, say for example, I've considered a picture. Say open the detail part and see the location and see the address. Every element or every picture or every audio clip you have in your mobile will have a particular address. The same way, every element in the memory will have address. So I will be storing A in the location 1000. Say for example, I have space over 2000. So I've stored my pointer in 2000 location. Okay. So this concept is being used in a linked list. So I'll show you how this concept is being used. So I've said you there will be only one head pointer and there can be any number of nodes. Okay. So my head pointer always points to the address of first node. My head pointer always points to the address of my first node. Say for example, this is my head. Did I start writing any nodes? There are any nodes in the list? No. So in case if there are no elements in the list, then it is placed null. Okay. I hope you have got understood. In case if there are no elements in the list, so you will be placing the head pointer or you will be assigning the head pointer as null. So my next one is nodes. My nodes have two parts. A node has two parts in single linked list. Okay. My first part is data part and my second part is next address. My node has two parts. First part is data part and second part is next address. Okay. So I will show you. Say for example, I have took a variable int a equals to 10. Okay. So this time in the linked list, I will be taking this data part and as well as we have seen what is linked list, right? You will be linking one element with the other element, right? It has collection of nodes. The same way, my 10 is connected to next element. So for getting connections, so I will be connecting with the next part. Okay, so I'll be taking two parts. So this is my actual data and I've been storing 10 value in a variable, right? So in linked list, you will take two parts. So this a variable as here 10, my data part is 10. This is okay. And the next part will contain the address of next element. Is there any element next to here? No, there are no elements. So this part contains none. Okay, I will be placing them in the location. So my first data part is 10. It is stored at the location 100. So I've been taking elements, I've been taking addresses like 100,000 so that you will be understanding the concept easily. So I might have addresses like 1, A, E, F, 1, 2, 4. So if I ask you what will come after 4 locations, you might get a little bit confused. So to overcome that, I will be using addresses like this. But in the memory, it actually changes. It gives random addresses. Okay. So my next address, I will be storing the next address. Is there any element after this? No, there is no element. So I will be writing none. Okay. So, and one more part you have to see is head always points to the address of my first node. What is the address of my first node? 100. So what will I be storing over here? 100, right? So this is called insertion in single linked list. Okay. So I hope you all have understood this, and I will be going with the operations with the linked list. So we have different kinds of operations in single linked list. My first important operation is insertion. Second one is deletion. And my third one is traversal. Okay. I have 3 types of operations in my linked list. First one is insertion. Second one is deletion. And my third one is traversal. Insertion can be done in 3 ways. Say, I will give you a real-time example. Say, for example, I'm into some food and I've been standing in a line. And say, for example, there was someone, some old woman or someone. I was standing in the first position. So I've seen her and I've given her the first position. Okay. Then who will be served first? That second person who came into my position, right? So this is insertion at beginning. Okay. Say, for example, there are 10 members in the queue. Okay, you've come to some tickets or something. There was some officer there. So he wants to come and stand in between. There might be any reason. So he asked you the, a position. So you have given, you were in the 5th position. You have given your position. So you will be going back and this person will be coming into your position. This is example for, insertion at a particular position. Or say, for example, you have stood in the line last. The other person who was coming, he started standing behind you, right? This is called insertion at behind. Insertion at the back. Okay. So I will show you the 3 operations with an example. My first one is at beginning, at a particular position. My third one is at back or end. Okay. So let me show you the example. Say I've given here, right? At beginning. Say for example, what is my first node over here? This one. If I have asked you to add at the beginning, you can call it as head also. So in case if I have asked you to add at the beginning, you have to add before this first node. So my node will be coming over here. Say for example, my node is 20. Initially, I did not establish any connection between them. Say for example, I've stored it over 200th location. Okay. So tell me what addresses are going to be changed. My head always points to the address of my first node. Now what is my first node? This has become my second node and this has become my first node. So this is my first node, right? Head always points to my first node. My first, at this point of time, my first node is 20. So address in my head is 200. Okay. So after this, I have established a connection. This is my second node. So I have deleted this part, connection, and my next node is 10. So what I've said, 20 is connected to its next node. How? This next address part will be containing the address of that second node. What is the address of 10? This is 100. So this part will be containing address 100. Okay. There is no other node behind this. Okay. So I will be writing null over here. This is called insertion at head operation. Okay. So first one is done. The second one is insertion at a particular position or insertion at back or end. Say for example, I wanted to insert an element at back position. Back means the first position is this one, second one is this one. What is the last one? This part, right? You have to insert element after this. Okay. So my element is some 92 and it is stored in the address 900. So initially there are no elements. So I've took it null. So, okay. So my first element, second element and third element. So I've established a connection. Here my front value won't be changing. Okay. Because I did not add element at head or at my, beginning of the list. I have added the element at the last. So my element is 92 and its address is 900. Okay. And there are no other elements after 92. So I have returned null at the next part. Okay. So after 10, my element is 92. So 10's next part will be storing the address of 92. What is the address of 92? 900. So I will be storing 900 over here. So this is in first position, this is in second position, and this is in third position. Okay. So this is called insertion at back. So when you want to insert at back, what you will see is when the data part's next part, okay, is null, then it is called as the next part. Then it is called as the last element. Say for example, this is my first element. How do you know that there are no elements behind this? Next part is not containing null, right? Then this is my first node, or there are some elements after that node. Say for example 10. You have 900 after 10. That means next address is containing 900. That means this is also not the last node. So that means there is one more element behind. So I went to the 900 location. So now it is 92. After 92, the next part of 92 is containing null. That means this is the last node. You want to add elements, you can add over there. Okay. Say for example, I wanted to add element some 36. My location is 600. These are random locations. I have used these numbers only because the concept will be easily understood by us. Okay. So initially it is null. Okay. So after connecting, so what happens? 92's next address will be containing the address of 36. Okay. What is 92's next address? This one, right? So null part is changed to 600. So this is what will be going in the single linked list. This operation is called as insertion at end. We have seen we have seen the example of insertion at beginning, and also we have seen the operation of insertion at back. Now we'll be seeing the insertion of elements in the particular position. Okay. So my first element is 1, 2 and 3 and 4. Now I wanted to add element between 3 and 4. I've set you this example. Say for example, I've stood 10 members in the queue and I've stood at the 5th position. Someone else came to me, even my place to him. So I will be going back, right? My position is 5, but after adding this person, my position went back to 6. The same thing happens over here also. So this is me and I wanted to add an element at my position. So I will be going to next position. I will show you. Say for example, my element is 62 and my location is 2000. Okay. I can use any, I will be using any random addresses. So, is there any other element after this? I did not establish any connection. So, my next element is, next part is null. Now, I will establish connections. So, I have added an element between 3 and 4. So, my third part is this and my fourth part is 62. And after this, my fifth element is 36. Okay. So, this becomes 5. Now, tell me what are the addresses changing. So, 92's next part is 600. But 600 is over here, right? What is my next part to 92? 62. 62 address is 2000. So, I will be making this 2000. So, after this, 62's next part is null. But there is an element after 62. So, I will be adding the address of this element. That is 62's element over here. So, this is changed to 600. Okay. This is the operation of insertion at a particular position.